Hi, everyone. Good afternoon, good evening, wherever you are joining us from. My name is Sharang Thaimade, and I represent Seed Global Education. And we have a wonderful session planned for each of you that have taken out time to join into Zoom. You're joining in from your laptops, from your mobile phones, from your iPads. Uh, There'll soon be your Apple Watches will also help you to join Zoom meetings and have conversations with people. I think that's what's coming up next, or maybe even Meta glasses. I think that's the new thing. So, like a lot of exciting things that are coming up in this world, and we've got a super exciting topic as well, and we've got two wonderful people here with us that want to talk to you. We are about 70 odd folks in this room. I'd like you to use the chat function and let us know which city you are joining in from. Let's use the chat function and let us know which city you are joining in from. I'll just quickly uh, mm, yeah. Oh, thank you, Dr. Pless, joining from Washington, D.C., and Kat Hugh as well. Jayendra is joining from Vizag, or Visakhapatnam, Maria from Delhi, Vizag, Hyderabad, Bihar. I think Arij has joined from Pakistan as well. Welcome. There is some folks from Vizag, so a large contingent here from Vizag, which is super nice to see. Hyderabad as well. Bangalore, Nikhil, thanks so much for joining us from Bangalore. So we've had people from Delhi, from Vizag, from Hyderabad, from Bangalore, from Pakistan as well. So the length and breadth of not only the country but also South Asia. Just for people who joined in new, please let us know which city you are joining in from, so that our wonderful panelists know where each of you are located as well. We are about 104 of this in the room. We are still waiting to start this session. We will in the next couple of minutes. We're just, waiting for the room to fill up and for us to be on our way. We've got Ansh from Pune, Ania from Delhi as well. Thanks so much for joining in. Patience is here from Accra. Welcome. We've got some contingent from West Africa joining this wonderful, exciting session as well. It's a pleasure. It is. I'm joining in from Mumbai. I think just for everyone to also know Mumbai, India. Chinmay is here from Pune as well. Um, let's quickly begin. We have a wonderful session planned, which is talking about photo geometry and measuring the world with AI and cameras. We'll be talking a little bit about unlocking 3D insight through AI driven imaging as well. We've got a specialist. We've got one of the senior professors from the George Washington School of Engineering, and he's going to be talking to us about this wonderful topic. And we also have a couple of more people, but I'll introduce them as time permits and as we move along in this session. What I'm going to quickly do is I'm going to run a quick poll question. And the poll question is going to be right on your screen right now. Before we move into the in-depth part of the topic, we want to learn a little bit about the audience. We want to know a little bit about how familiar you are with AI tools for analyzing live video or image data. It's a poll on your screen. If you can't see it, click on the poll button on your respective laptops, computers, mobile phones, iPads, wherever you're joining this from. We have close to 45 of you who've answered this question so far. Waiting for a few more people. This is going to be on your screen for the next few minutes. Are you very, very familiar with them? Are you somewhat familiar with them? Not familiar, not very familiar, or this is completely new to you? And we just want everyone in the audience to know what kind of people we have in this session and how much do they know about photogeometry and 3D insights into AI-driven imaging. It's certainly an exciting session, and this is going to this obviously has gotten 600 plus folks interested. So if your friends haven't joined yet, tell them we're starting in a minute, and this should be good. Okay, so we finished a large part of this poll. I'm going to share the results for our wonderful faculty member and also for the audience. There are close to 75% of you. That's incorrect. That's 60% of you who have some bit of familiarity between this particular topic, and about 40% of you are not as familiar. So that's the approximate ratio. It's a 60-40, Dr. Pless, on the doing this topic, and the balance 40% you are going to be much more familiar by the end of this session. Very quickly, I'd like to invite Dr. Robert Pless, and I'm going to give a very, very brief introduction of Professor and Dr. Pless, who is the chair of the Computer Science Department at the George Washington University and the School of Engineering. He has a bachelor's degree in computer science from Cornell and a PhD from University of Maryland, College Park. And he was also the faculty of computer science at the Washington University in St. Louis, and he's done some wonderful research on geometrical and statistical computer vision. Thank you so much, Dr. Bless, for taking our time and doing this session. We are very excited, and the 186 folks here are also super excited, and we can't wait to learn from you. So less of me and more of Dr. Bless.
Well, thank you for that really, really nice introduction. I appreciate the chance to talk to you, and thank you for organizing this, and thank you to everybody for taking some time out of your day to listen and learn more about this kind of research. So I have been working in the area of trying to understand the world through images for a very long time. And one of the things I've thought most carefully about is trying to use webcam data from cameras that other people are already placing around the world for whatever reason to reorganize them to be able to measure things that are interesting. And I've done this as a very long-term project, and it is AI, but not just AI in the sense of the very modern deep learning approaches, but AI in the sense of let's do anything we can to understand something about the real world from these images. And so I started in 2006 capturing images from publicly available webcams. These are cameras that countries put along their highways, or cameras that random stores put just to show their parking lot, or beach cams, or so cameras that are everywhere. We found cameras most easily in the United States and Europe. This picture is a little bit out of date. There's more and more cameras in the rest of the world now, but still less than in some places. And these cameras collects fascinating pictures of the world, but also have some very common and interesting error modes, which make it more fun, but also more hard to work with them. So a lot of times there's fog in the pictures. There's a camera that has literally been taking this picture of this brick wall for 21 years. It I think was mounted on a rooftop. It fell off. I don't know why the IT department is good enough to keep the camera running for 21 years, but the that nobody could like tip it back up. But I think sometimes these become interesting accidents where now we have a really amazing view of how bricks decay over a really long time. Like if you want to know real world changes to bricks, like how do they decay? Like this is probably the most interesting data set for that, like outside of a lab. There's raindrops that come on the cameras. There's various technical error modes where something is wrong with the electronics. If the sun is looking straight in the camera, just like if you look straight at the sun, it's really hard for the cameras to see, and sometimes there's condensation in. And so when you really put cameras out in the world, some crazy things happen, but also you can see very interesting things about what's happening, like how people are using public spaces, how the weather is changing in different places. You are looking sideways through the atmosphere. So unlike satellite data, which tries to tell you something like where there are clouds, this tells you at what altitude there might be different atmospheric effects. And we have lots and lots of cameras, but they're close enough to the ground to see individual things, so we can measure things about how specific trees are changing over time instead of just summarizing information over an area like most satellite data. So I've been thinking about every possible way to understand images from large cameras of these. And just to give a little bit of insight, when you just put together data like this in different ways, it often makes very interesting pictures. So here is for this camera, a summary of all the pictures we captured over a year, organized by what time of day it is across this montage image, and day of the year going down. And so this already captures things that we all know, but the days are shorter in the winter than they are in the summer. And we can see interesting biological patterns like the trees get their leaves about this time of year and they lose them at this time of year. And you can even see some things like what kinds of weather there are at different parts of the year in this sort of summary picture. So I have been trying to think about how to organize this and understand lots of things. And I'm not going to talk about this today, but one question that's interesting is if you just have the feed of a webcam, how can you figure out where in the world it's from? So if it's a webcam, you find it maybe with a URL, and sometimes that URL says Washington, D.C. webcam, and then you kind of know where it is. But sometimes it's a camera that just has like an IP address, and you can look up the IP address, but that goes to like the address that it's registered, not necessarily where the camera actually is. And so we worked to play games like how could you figure out where in the world the webcam is just from the image data. But today I want to talk about some stories about the understanding transient effects or transient objects that are in the scene and see if we can learn something about the world from these cameras. So I have a couple short stories about this. And then later we're going to come up with understanding the structure of the scene. So in one case, we have these cameras and they are watching the ground from relatively close by so we can see things like individual trees. And one of the big questions that is affecting our understanding of climate change is to really capture at a global scale when trees get green in the spring and how long they stay green and when they stop being green in the fall. And this is important because measuring this is a sign of changing climate, if that is changing over time. And it also is one of these climate changes that is really important because it feeds back on itself. Like as the CO2 as there's more CO2 in the air, maybe it's the case that trees can grow more quickly and grow longer. As the growth season is longer, maybe it's the case that the trees stay green for longer and capture more of the CO2. Or maybe it's the case that because the temperature is getting higher, the trees are less healthy and then they are less effective at pulling the carbon dioxide out of the atmosphere. And so this is not just something that can measure the CO2, but is something that's really important for understanding how that feedback may make the problem worse um, even more quickly than it is. And so what's the current state of the art in doing this is usually to use a satellite called MODIS, the medium resolution orbiting density. It's a satellite. And one of the problems with MODIS is it captures pixels of the whole Earth, but each pixel is about a kilometer by a kilometer. And so you can't see individual things very well. And if you look at things like specific webcams, then we can see like here, there aren't very many trees, but if you draw a box around the trees that are there, you can see like these are real trees. And when we say it gets green, we can go back and look at it and be very sure because we're looking at the tree. And so we can find the trees in a scene like this. We can measure how green they are and get a day from after the beginning of the year. So 100 days after the beginning of the year is sometime at the end of March. And we can check to see if these are accurate. And if we compare this to, so this is from from St. Louis, the university I used to work at. We look at a particular tree and we can see when it gets green. And in this particular scene, the satellite says that the trees in this area get green here. And the reason for that is the satellite is often confused if there's areas with lots of grass. That as soon as the grass gets green, then the satellite assigns that pixel of the Earth to be green. And it doesn't really understand the difference between grass and trees because from the atmosphere, you can't really tell. So one of the very exciting things that we've been able to do is to make a very small change in one of those many lines that is predicting the possible impact of climate change by correcting the satellite estimates of the spring green up time for trees for these regions where there's some trees, like enough trees to matter, but where there's also enough grass where the satellite gets confused. And this, the AI that was done in this task is not really shown in this picture. Like this picture is literally just calculating how green this pixel is. That's not very much AI. But scaling this up to large number of cameras was an early application of image recognition where we took our 30,000 webcam images and wanted to automatically find regions that had trees and especially regions that had trees whose greenness changed over time. And then we could just use the regular pixel values to actually measure the greenness score. A second kind of thing that you can watch to understand dynamic events and how the world is changing is to explore changes in how people use public spaces. And so in the United States, about 10 years ago, there was a big push to have more bike lanes that were installed. So I think here is the installation of a collection of bike shares in New York City. It's not there 6 months before this. In Washington, D.C., we had the same thing where there was additions of crosswalks and also additions of bike lanes. And the groups that were trying to promote the additions of bike lanes had very good ideas of that this would increase the number of people walking and biking, but they didn't actually have any measurements. And the classic way to do that would be to send a surveyor out to maybe watch how many people are using things. But our webcam archive was actually capturing sort of by accident all of these areas to understand how many bikes there were before and after the installation of the bike lane. And we were able to come up with a kind of funny conclusion that says when you put a bike lane in, it isn't the case that many more people ride bikes on most days. In fact, on the days that are nice, the same number of people ride bikes. But if you have, this is for like inside cities, if you have rainy or bad weather days, people are more likely to bike if they have a dedicated bike lane because they feel safer than if they don't. And so at least in the first 6 months, like before and after the installation of a bike lane, on the good weather days when there's a lot of people biking, there's no observable difference in how many people bike. But on bad weather days, you get many people using that. And I think that makes sense because I don't think anybody comes home one day from work and says, "Oh, there is a bike lane. I should now buy a bike." I think what happens is people that like to bike will bike more often if they feel safe. And then maybe in a longer term, like over 5 or 10 years, like the places that have bike lanes attract more people that like to bike. Um, so that was one kind of measuring. So measuring, like looking at scenes and trying to understand changes that where if you understand them, you can make better policy or understand more about the world. Another question is to say, let's try to measure, like really measure, like what is the 3D structure of the scene? And so here we have a time lapse where we were watching a scene. This is in the Czech Republic, and it's just a partly cloudy day, and we can watch the clouds go overhead. And I really like watching pictures like this. Maybe I'm impatient, so I like watching time lapses. But also here's a case where like you can learn a lot about what the world looks like by watching how these cloud shadows go overhead. And so we said, I wonder if inside this video data, there's enough information to build a 3D model of the scene. And so the approach goes like this. Let's look at the video. And a lot of people think of videos as a large number of frames, right? So a video is frame one and then frame two and then frame three, and eventually you get like 1,000 frames or 10,000 frames of video. And that's one way to think of video. Another way to think of video is to say, instead of thinking of a picture as the dominant thing that the video is constructed of, let's look at one pixel. And if I take this very myopic view of the video, I can say this pixel changes over time. It gets brighter and darker and brighter and darker and brighter and darker and so on. And the video is just the collection of all these pixels getting brighter and darker. So you can think of it as frame, 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 or you can think of it as a whole bunch of pixels and each one is getting brighter and darker. And that second viewpoint is an interesting way to think about analyzing video. And so we can look at this one pixel, and this is the actual pattern of how this gets brighter and darker. So it's like it's a little bit darker, maybe a little cloud goes overhead, and then the sun comes back, a little cloud, the sun comes back, and eventually a big cloud goes overhead, so it gets really dark, and then it gets brighter again. So I can make this signal of the brightness of a particular pixel. Then I can take the signal of every pixel in this video, and I can say how correlated are all the pixels in this video to this one pixel. So this pixel has a perfect correlation with itself, and it has a very high correlation with the pixels that are nearby, because if you're nearby, then you're likely to have the same clouds going overhead. And if you're a little bit less nearby, then maybe the same clouds go overhead, but at a slightly different time. And if you're really far away, maybe totally different clouds go overhead. So there's a correlation between there's a relationship between how correlated these signals are and how far away the pixels are. But it's not how far away the pixels are on the image, it's how far away the pixels are in the world. And so that gives an interesting constraint. So we can make this colorful picture, this false color picture that says how correlated are different parts of the scene with this pixel. And we can make that for many different pixels. And so here's 4 viewpoints. So centered at this pixel, I get this correlation map. Centered at this pixel, I get this correlation map, and so on. And I call these pictures God's flashlight because it's almost like you have somebody that changes the world to paint it all this brown color, and then you shine a flashlight over some particular spot, and now you're observing that. And so it gives you this decomposition of the scene into relationships of depths of the object. And now what we want to do, if we want to build a 3D model, is we need to learn what is that relationship. Like if I am this much correlated, does that mean I'm 10 meters away or 20 meters away or 100 meters away or a kilometer away? And if I'm less correlated, how much further away am I? So we need to learn a distance to correlation map. And so learning that map is an optimization problem. You can do it in a number of ways. All of AI is essentially an optimization problem. And so our approach is to do something called alternating minimization, which basically means guess at something and then update your model and then guess again. So if we imagine that the world is a flat plane, then between every 2 pixels, so this is a wrong assumption, but it allows us to measure. If I believe the world is a flat plane, then between this pixel and this pixel, I can estimate what the distance is. I can use the model to tell me. And from the video data between those 2 pixels, I have some correlation. So every dot on this picture corresponds to a pair of pixels in my image, and I'm measuring the correlation from my video, like from these pictures. And then I'm looking at the distance that my model has computed. So that gives me all the black dots. And then I can fit a best fit relationship between the distance and correlation as the green line. And now I can optimize something to say, if my correlation is, say, 0.4, I'm going to assume my distance is this far. And so then I get a bunch of constraints between all my pixels that say what that distance should be, and you can convert that set of constraints into a 3D model. So I'm going to play now. I'm going to play these two at the same time. And so as my 3D model improves, I get better estimates of the distance. And as my estimates of the distance improve, I get a better 3D model. And so you can run this optimization and pull out a 3D representation of what this scene is. And so this is something that just comes from understanding the relationships between the correlation and distance and being able to measure that correlation over the course of the video. And you can play this game with all sorts of videos. So here's a video where everything is closer together. And so the relationship ends up being more linear. And we can show the scene and then the initial depth map and then the final depth map. And so here are some more examples of these God's flashlight pictures because I just find them really fascinating. All right. So then the last little story I want to tell today, because I'm trying to be good about time. My last little story is to say one thing you might want is 3D structure, but the other thing you might want to do is to understand when you look at a scene, what parts correspond to the same objects and what parts correspond to different objects. So here's a video. I like looking at incredibly boring videos. It helps like make sure you look at this. There's actually things moving, right? So this is a forest and there's some trees waving in the wind. They're not waving very far, but they're waving in the wind a little bit. And one of the kinds of questions you might want to do is to count how many trees there are or segment them so you can learn something about each tree. And that's a really hard task. If you had this as a static image, it would be really hard. Like maybe you could look at it and say, okay, like that looks like the top of an image and it seems separated from the things behind it. But it's a lot easier to be able to say, like, all of these things are moving at the same time. So we use a technique called principal component analysis. In the AI world, that's considered the simplest of the unsupervised learning techniques. It's a clustering technique. And we end up clustering each pixel by its time series trajectory. And there's a couple ways we can think about this, but one of them is to say, let's take my original video and let's run principal component analysis, which says, let's find the image regions that explain the correlated changes. And let's find the image regions that explain the correlated changes. And then, so this story says I can reconstruct my original images by taking the average image here, I've made it grayscale, and then adding or subtracting different parts of these principal component images. And that's what that. And then I can take those principal component images, say what X direction motion would be most correlated with creating this kind of change. So what kinds of shifts in the image would create this kind of change? And then I can merge these into one false color image so I can see everything that's happening all at once. And so when I merge those, I get a segmentation of the scene into regions that have consistent motion. So this purple color seems to correspond to this tree because all of the pixels in that tree were moving in a correlated way. So this becomes a very nice representation to allow you to segment things in the scene, and then you can do downstream processing like figure out how far they move or figure out how many trees there are and so on. And this particular approach is super resistant or robust to noise. So here we have our original video and I've added more and more and more noise to it. And then to see how the approach works. And even this picture where you basically can't see the motion anymore. If you look, it's really hard to see the motion in this scene. We can still use those motion cues because they're consistent over time in a way that the noise isn't consistent over time in order to segment the video. And here's another example of a scene. This is less complicated of a scene in terms of segmenting the video. These are Shiba Inu dogs. This was, for some reason, a famous video on YouTube a long time ago. So it's not so hard to tell the difference between the two dogs, but if you look carefully, you can see that they're moving. Like this dog is sleeping. So if we were to take the principal component analysis of this video and try to find the pixels that have correlated motions, we get a motion like this. We get the images that look like this, and we can solve for the consistent motions. And then if we look at how much of this component you need to reconstruct the original images, then you use like the red amount of that component. And so this is pulling out the breathing rates of the two different dogs because they have completely independent breathing that goes on. And it's all exactly the same code that is used to do the segmentation of the trees. So that is a couple short stories about some of the variations of old school artificial intelligence that we've used to try to understand images in the wild. We have a new project recently that is trying to do more agentic-based video discovery. So if there is something that is important, can we, instead of just having the cameras already in our index, can we set some AI agents loose and go find the video data that's most important to us by looking through live, like for example, for live feeds in a YouTube, like in the YouTube live feeds. That's really exciting. We have a project that's trying to use that specifically to discover where in the world there are contrails, because contrails have a very big impact on global warming also. Not the contrail itself that the airplane leaves behind, but if that contrail spreads out into cirrus clouds, it can blanket the Earth in a way that is much more global warming inducing than just the CO2 that is produced by burning the energy. So I will share that I am always excited to get technical questions from anybody. Here's a overhead view, an artistic overhead rendering of the GW campus. This is the Science and Engineering Hall. I used to have this office, and now I'm on the back side of this. Um, so I am open for technical questions and details about our application process, and some of the university policies are coming up with the next speaker.
Wonderful. Thank you so much, Dr. Bliss. I think that was wonderful. Lot of insights, quite intriguing and very focused masterclass. We have 12, wonderful questions that's there. But for the 230 of you that are here, thank you so much for all your questions. Please do keep them coming. Please do keep all the questions coming in, because we have our next speaker, who I'm going to very quickly bring on to you. I'll let Catherine do her own introduction, but she's been with the George Washington School of Engineering for the last 3+ years now, and she's the best person when it when it comes to knowing more about the university, the programs, anything under the sun around admissions process, and like how you can spend some time at GW and learn from Dr. Pless in person, if not online as well. So less of me, and now over to you, Catherine.
Thank you so much, Sharang, for introducing me. And Dr. Pless, thank you for sharing your research. It was so fascinating. As somebody who didn't study engineering or computer science, I learned a lot. So I really appreciated that. But for now, I'm going to do a really brief overview of George Washington University and specifically the graduate programs that we offer here at GW Engineering. Like Sharang has already said, my name is Catherine Hugans. I am the Associate Director of Admissions and International Partnerships in the Graduate Office. I've been with GW for quite some time at this point in a couple of different roles, so I have a lot of expertise in international credential evaluations, visa documents, admissions, application requirements, and all of that fun stuff. So I'll be happy to answer those questions after I'm done presenting, but for now, let's just talk a little bit about the importance of really selecting the best graduate program for you. One of the things I always like to remind students is that there are over 4,000 universities in the United States. So, and that's again, not even considering schools outside of the United States. So it's really important that you are considering what is going to be the best fit for you. So looking at the quality of the program and the faculty, doing your research to see what are the professors doing at each institution you're considering? Where's the actual location? Do you want to be in a city like Washington, D.C.? George Washington is right downtown. We are in the heart of the city. We're about 10 minutes from the World Bank, the IMF. We're close to large government agencies as well. So there's a lot going on. We're an urban campus, meaning that it's easy to get to and from your apartment to campus, to your internship, to whatever fun things you want to do with the metro. But maybe you want to go somewhere, maybe a city's not the right place for you. Maybe you want something more rural. That's something to consider when you're looking at universities. Also taking into account the facilities and the resources that are going to be available to you. Is the university going to have the resources that you need to do the research that you want to do? Is the facilities available for you for the type of life that you want to have? Do we have a gym? Do we have a library? What do you have going for you? And then also taking a look at the career services and alumni network. We'll certainly talk a little bit more about the career services here at GW specifically, but in terms of our alumni network, we have over 300,000 alumni worldwide, many of which are from parts of the world where you all are phoning in from today. Not really phoning in, you're on Zoom. That's an old expression. And then the types of financial assistance that are available to applicants and students, which again, we're going to talk a little bit more about what that looks like for you if you do apply to GW Engineering. So first thing, some brief information about the university as a whole. We were founded in 1820, One, by an act of Congress, we are unique in that we have a predominant graduate student population. So we have 10,000 students studying at the bachelor's level. We have about 15,000 students studying at the master's and PhD level. So research is definitely a large component of our university. We are an R1 research institution. We are made up of 15 colleges and schools throughout the university, and we're spread across three main campuses in the DC and Virginia region. Our main campus, like I already mentioned, is in that Foggy Bottom neighborhood in downtown DC. We also have the Mount Vernon campus, which is in Georgetown, a neighborhood in DC that has some more residential dorms for undergraduate students and some athletic facilities. And then we have our Virginia Research and Technology Center out in Northern Virginia, out near the Dulles International Airport, that if you do come to DC, you will be flying and landing in at that airport. But of those 14 colleges and schools at the university, GW Engineering is one of them, and that's where we are speaking to you from today. Dr. Pless and I both work at the School of Engineering and Applied Science. We are made up of 6 academic departments, so one of them, of course, is computer science, which Dr. Pless is representing today. We also have academic departments in biomedical engineering, electrical and computer engineering, civil and environmental engineering, engineering management and systems engineering, and mechanical and aerospace engineering. Across those 6 academic departments, we do offer 11 different fields of study at both the master's and PhD level, and I'll share a list of what that looks like in a moment. And we have 80 plus tenured and tenure track faculty members who are there to, of course, share their expertise in their field of study and to teach your classes and to be your advisors. We are unique in that you will have a number of advisors during your time at GW. So if you are enrolled, if you come to GW, you will have a professional advisor, which is somebody in my office. That would be a graduate advisor to make sure that you're keeping on track with graduation requirements, that you, if you have questions about registering for classes and the forms that you might need to fill out, they're there to really help you with the technical aspect of being a graduate student. And then you'll have a academic advisor, which would be actually a faculty member in your department who's really there to be the content expert in the field that you're studying and to really help you to navigate your degree program and your areas of interest. And then you'd also have an international services advisor to make sure that you are maintaining legal status while in the US. And that would be in our international services office. So we try to make sure that you have all of the support necessary to make sure that you would succeed in your graduate program while at GW. Now, I mentioned resources earlier, so I do want to highlight our Science and Engineering Hall, which is the main hub for our students. Dr. Plush showed you that lovely rendering of it earlier. Here is a great photo of it. It is LEED Gold certified. We have a large number of research labs and other areas, including a Class 100 nanofabrication clean room, a high bay with a strong wall and a strong floor, some high resolution imaging suites, as well as some interdisciplinary research spaces. So along with our engineering school, a lot of our hard sciences and our School of Medicine have research spaces within this building. So you do get that opportunity to really connect with other students and other schools while in the Science and Engineering Hall. It's also where all of our administrative offices are, and the majority of our professors have their offices in here as well. Now, in terms of the degrees that we offer, this is the list of the master's programs that we provide. Our master's programs are typically 2 years in length, and the majority of these would be thesis optional, meaning that it would be up to you to decide whether or not you would like to pursue a thesis in the later part of your program. And then at the PhD level, if you're more interested in further research, if you know you want to get a doctorate, these are the programs that we offer those. And our PhDs are typically 4 to 6 years in length. It would depend on whether or not you are coming in with a prior master's. We do allow students to apply direct entry with only a bachelor's, but the thing to note, of course, is that that is highly competitive, and we would be looking for demonstrated experience in research, potentially some publications to your name, and other things like that. Now, in terms of scholarships and funding that I just want to highlight, at the master's level, when you apply, you will automatically be considered for one of these merit-based scholarships from my office, the Office of Graduate Admissions. These scholarships range from 25 to 75%, and they are merit-based, so that means we are looking at your performance in your undergraduate studies, the strength of your letters of recommendation, your resume, CV, and all of that information together. At the doctoral level is where you'll see the more common full funding that you might be more familiar with. That's where you might be offered a teaching or research assistantship where you would work directly with your faculty advisor and you would receive full tuition coverage and potentially a monthly stipend for living expenses and other things like that. If you're applying for a PhD program, you would be reviewed directly by the faculty in that academic department, and the funding would be coming directly from them. So my office would really just be involved to help make sure that your application is complete and prepared and ready to be reviewed by them. I do also want to highlight our W. Scott Amy Career Services Center. They're located right in the Science and Engineering Hall, like I mentioned earlier. And they're really there to help you to prepare for the job market once you graduate, whether it's after 2 years or 5 years. They're there to help with resume building, cover letter assistance. They'll often bring employers to campus for career fairs or potential interviews and other visits and networking events. You are always available to make an appointment with their office, and I encourage you to visit their website if you'd like. And I do also want to let you know that one, this office exists because they are experts in the engineering field. You do also have access to the general employee career services office in GW in the University Student Center. So you have a lot of different support available to you as you navigate internships and potential postgraduate career opportunities. And then, of course, I just want to highlight the benefit of being in Washington, D.C. and at George Washington University. So for one thing, we do have smaller size classes, which allow you to really get to know your faculty on a one-on-one basis. And you get to benefit being in the nation's capital and connecting with wonderful research projects from around the city and throughout different government agencies and companies, which is a great highlight of one of the benefits of being only at GW. And then I do want to highlight, in case you weren't aware, you do have the opportunity to connect directly with one of our graduate ambassadors. You can chat with them directly. I've highlighted a few, though we have some others as well. We have students from all over the world, ranging in master's and PhD programs, and you can directly chat with them and ask about their experiences. So if you're interested in computer science after hearing Dr. Pless's lecture today, feel free to send Knock a message, ask her about her experiences in the master's program in CS. I'm sure she'd be happy to answer any questions you might have. And then that is it for my presentation. I do want to just mention that because you've attended today's session, you do qualify for an application fee waiver. That fee is going to be SEED MC 2025. So please feel free, take a note, jot that down, take a screenshot. If you do choose to apply to GW following today's session and use that code, the application fee will be waived. But now I want to open things up for our Q&A. I know there have been some questions coming in for Dr. Pless and for myself, and I'm sure Shirang has already been looking through those and is ready to present.
I do. Thank you so much for that, wonderful place to go study. Heart of DC, very close to, some of the important places in the world, is something I can mention, especially the Foggy Bottom campus. That is a stone's throw away distance from a lot of important buildings that are of not just national importance, but international importance as well. Dr. Pless, and Catherine, thank you for your wonderful presentations. We're right on time. We're about 15 minutes to go. And, I have some questions that are already, in my mind and in here. And I'd also like to thank Dr. Bless for some of the content that he has been responding to these kind of questions through the chat itself. For the 200 of you that are still here, 208 of you still here, if you still have any questions, please use the Q&A tab. We will be asking some of those questions. I'll start with you, Dr. Kless. There was an interesting question that actually caught my eye, which talks a little bit about career opportunities with the masterclass that you have, done, talking about this topic on photogrammetry and with the advent of AI. What are some of the career opportunities, or what are some of the roles? What kind of companies actually hire students that specialize in something like you do?
Yeah, so the area of computer vision, which is sort of like the big area of this, is super popular at especially, well, across many different kinds of companies. So the big tech companies, the Google and Amazon and Facebook, are all trying to understand how to make services that use computer vision to help. So Facebook wants to automatically recognize the people in your pictures so it's easier for you to tag them and it's easier for them to build community with you. Amazon wants to take pictures to understand inside their own warehouses how to do things better and how to maybe respond to user queries for things they want to buy. So lots of the big tech wants to do this. I think there's also a really strong startup culture in the area of computer vision where instead of it being from the big scale, you do it from the small scale. Like we have there's so many options, but people like trying to look at something in healthcare and saying like, can I make an app that takes a picture of the rash on somebody's skin and gives them advice about, is this one you really need to go see a doctor for or not? And some of those things are approachable from more of a small startup company. We have a project right now with a group at the World Bank that is trying to look at donated supplies for regions that have like a hurricane or something that has come through, so some kind of natural disaster, and trying to say like somebody just drove up with a big box of shoes and diapers and water bottles or something, right? So right now somebody has to type in like box 17 shoes and diapers and water bottles, but maybe just a camera that looks at it and can automatically generate sort of the log of what that is, and then it can go to the right place. So I think there's the big company that's trying to do something that a billion people would use, and then there's small companies that say like, here are 30 people's jobs that I can make easier, and you can attack it from both sides. The big companies, um, like there was somebody like that asked like, do you need a master's degree to get this kind of job, right? And I think at the big companies, the answer is basically yes. Like they have enough people that are applying to them that like they mostly want some more of that training. And I think a field like computer vision is one of those that's really useful. If like as an undergraduate, you might have a really good strength at programming or something, like you can write a good program. But computer vision is this combination of a fair amount of statistics and some medium complicated programming and some understanding about optics and how the world is changing. And so it's just hard to get all that at the undergraduate degree. And I think if you were to go to a master's program and take the AI and computer science classes, you get a stronger background, and that's what those companies are looking for. I think if you're going the startup company route, like it's a little bit more just on you, right? Like some people have that thing where they can just go convince people of anything, and it's kind of a fun time. Like 5 years ago, it was really hard to make a computer vision system that actually worked in the real world, and now building on top of some of the deep learning tools, that's more feasible. So it's more approachable from small startups.
Wonderful. Thank you so much, Dr. Bless, for that elaborate answer. And I think that you've also covered a couple of other elements that were part of my next question, but I think we've saved everyone some time, in that regard. Catherine, there was a question, interesting question about visas, and I know that you have great expertise on that yourself. As someone from the admissions team of George Washington, how do you support students when it comes to the next part, where application, etc.? I know you provide information, but once, let's say, they have gotten an offer from GW, what are some of the next of services, let's say, that you provide as an admissions or in terms of admission support? Because it's a question about, will GW facilitate helping get visa interview slots, since the slots are made considerably limited by the government?
Yeah, I definitely understand that question. I can talk a little bit about the resources that we have on campus, and then some external resources that I'm aware of. So obviously, if you are admitted to GW, you would be working very closely with our office. We have a staff member dedicated to helping you go through the process of getting your Form I-20 to apply for your F1 visa. So they'll be there to answer any questions you might have about the documents you need to submit, the type of financial documents that we require, how much funding, things like that. The International Services Office would be the one to actually issue the document, but they will work closely with you more once you're on campus. Once you receive your I-20, they'll give you a welcome packet with some really wonderful information and support guidance that you can utilize. Unfortunately, we do not have the capability to help students individually request visa appointments at embassies or local consulates. The State Department has been very clear with universities that that is not something that they allow us to do. They do not want to see letters from us requesting appointments on students' behalf. But we do, of course, connect students with Education USA that have services all over the world. They are a wonderful resource because they are actually connected to the State Department, but their entire purpose is to help students like you who are preparing or who are interested in studying in the US. They will often bring consular officers to their offices or do Zoom calls like this, where you can hear directly from a consular officer about what to expect in a visa interview. The EdUSA advisors will allow you to make appointments with them to actually do a one-on-one consultation and maybe a mock interview, and they can really help you to prepare for those appointments. In terms of the availability of appointments, that is up to the individual embassies and consulates themselves. I have no discretionary ability to help in that regard. Some embassies have a higher number of staff, and so they have a larger capacity for processing visas than other embassies and consulates. It just depends on where you're located, and what your options are in terms of processing. But we are there to assist. And if for whatever reason something might happen where you maybe aren't able to get that appointment in time, we do have options to potentially defer your admission to a future semester, which does allow you a greater amount of time to get that visa interview slot. And if that happens, which would be much further down the line for any of you, you can reach out to our office and we'll work with you about what that looks like.
Wonderful. Thank you so much, Kat, because that also answered Abhilash's question on if the admission can be deferred if the visa is not referred on time. So, Abhilash, yes, I think Kat answered that question, and it was a resounding yes, if that. But one quick, comment on my end, and seeing students through this process over the last few years, you can look at some of the visa slots in different consulates in the city, maybe, sorry, in the country rather. I know that usually if the slots in Mumbai or Delhi are full, people usually take a flight to Chennai and try and attend their visa interview slots there. So that's an like additional effort that you might have to take in that regard. Dr. Bless, my next question would be to you, and since this topic about photogeometry and the imaging has evolved over the last few years now with the advent of AI. And you did talk a lot about what AI and how AI has impacted this particular industry. But would you like to quickly summarize how this sector or how this topic has changed in the last few years with AI being readily available and useful in this regard?
Sure. So I think one of the biggest things is that a couple years ago, these like computer vision was something that you could focus a lot of effort and try to attack a particular problem. So people did that for lots of problems. But for example, like you could build something to say, I want to analyze X-rays and say, here is somebody that has a lung X-ray, like do they have a tumor or something? And you could build a very focused tool on one problem. And what's happened in the last couple years is that the tools have opened up where they combine natural language and images. So you can take a sort of image and ask a question in English, and the system can understand the English well enough to know what the question is about and understand the picture well enough to be able to answer that question. And like it's amazing, right? Like it's amazing that you can do this and basically take people like me out of the loop, and that's good. I think one of the things that we're discovering now is that AI in almost all things is a really, really, really good for the 90% solution. Like it convinces you that it's good because usually it's introduced as solving a problem you have no other way to solve. So like Google search, like there's however many billion web pages, you could not search without something like Google search. And so you use it and you're like, wow, this is pretty good, right? And actually somehow Google search has convinced you if you don't find the page you're looking for that it's your fault. And you like, oh, I need to search a different way, right? And I think what we're discovering now is for some AI things, like where it's like the good enough answer is okay, right? Like on your smartphone, you can now like automatically label the pictures by who's in it, right? And if there's some mistakes or if it's a really dark thing, you don't care because it's so nice to have all these pictures organized. But as we start trying to use the AI tools for really high stakes things like like actual diagnoses in for doctors to replace the doctors, right? We're discovering that it's really hard to get rid of that last 10% of mistakes. And so I think that's the big change in the field in the last couple of years.
Wonderful. Thank you so much for that, Dr. Bliss. I think that covers a couple of questions asked about, some of the new age technologies and how it's impacting this particular industry. We would certainly have to ask you, Catherine, and if you'd like to also throw some insights, Dr. Bliss, about some of the recent developments, especially over the weekend on the new rule with regards to H-1B visas. There are 3 to 4 questions on that, and I'm sure it's on the minds of all the 180 of them. I've already got, messages on personal Zoom chat saying that, hey, please ask my question, please ask this person's question. So yes, we are going to talk about the elephant in the room if we've reached that far already with the H-1B visa status. What is, how is it going to impact students? What is your stance or GW stance on how it will impact, like Indian students, because 70% of H-1B visas are going to Indians. I'm not saying Indian students, but Indian. So how would you like to comment on that, Catherine?
Yeah, definitely. I'll preface this by saying I can't say that this is GW's stance by any means. I haven't gotten any messaging from leadership or anything, so this is purely my own answer. You'll just have to make do with that as you will. And the first thing I would say is, of course, one, obviously, I saw the news this weekend as well, and one of the key things to remember is that all of the implications of this new proclamation are not fully understood yet. Um, I'm sure you've seen confusing news stories with contradictory information as some announcements have been changed and brought back and everything. The thing to keep in mind, of course, is that H-1B is for employees and for people who would be much further in their time in the United States than any of you are at this point in time when you're considering you're applying to the United States for a graduate study. So what the process might look like 2 to 5 to 10 years from now, when you might actually need to qualify or apply for an H-1B visa, might look very different. Administrations change, regis uh, regulations change, things of that sort. What I can say is that at this point in time, there's been nothing to indicate that they're considering making changes to CPT and OPT, which are actual real benefits that all F1 students can potentially take advantage of. We didn't talk about it, but I can mention it very briefly. CPT is curricular practical training, and that's what allows F1 students, which most of you would most likely be studying on, to do an internship during their academic studies at a job or internship related to your field of study. You usually are allowed to do CPT after you've completed 1 full year of your program. And during the summer, you can work full time, more than full time. As long as you're not in the school year, you're not limited to 20 hours a week. So you can work 60, 80, however many hours. I've known students who like to suffer. That's their fun. After you graduate, F1 students get the benefit of OPT, optional practical training. Um, OPT is what allows F1 students to stay in the United States, still on their student visa, and get work experience in the US. All F1 students are eligible for at least 1 year of OPT, but students in select STEM programs are actually eligible for an additional 2 years on top of that 1 year, so a total of 3. All of our students at the School of Engineering qualify for that STEM OPT extension. So at that point, what happens if you do OPT and you do the STEM OPT extension? The H-1B process might look very different. Um, the current proposal for this new fee might not exist, or it might be very clear about what those implications look like, and we'll have a lot of resources available to you in the International Services Office. But what I would say is that headlines can be misleading. They're trying to get the most amount of eyes and clicks on their stories. So don't panic just yet. Please reach out to whatever schools you're interested in. We are here to help and support you. But also keep in mind that not everyone does get an H-1B, even if it might be the goal of some. But the strength of a US degree still has merit and weight, whether or not you're planning on applying for an H-1B or what those regulations might look like. I hope that answered something. I'm sure it didn't ease many anxieties, but that's okay. We're going to be here to help you, and we are with you through it all.
Absolutely. Thank you so much for that, Catherine. And she makes a very important point. The earliest any of you would apply for an H-1B after you finish your F1 visa or convert your F1 visa is, let's say you start a program in 2026 or 2027. It's a 2-year program sometimes. That is, let's say 2028, and then there are 2 to 3 years of OPT if you consider doing that. So that is 2031. Now, a lot of us don't know what we're doing next week, but we certainly don't know where we will be in 2031. That's 6 years from now at the very earliest. So, yes, this news is like not the kindest for us at this stage, but what's going to happen 6 years down the line, I'm sure that none of us have that much foresight to actually confidently comment on the future of Indian students in the US. So just to keep you on that particular note. That's about it for the time that we have. Any final thoughts, Dr. Bless, about this session, about the topic that you'd like the 150 of us that are still on this call to go by, and any final thoughts from you, Kat, as well, on what students should do when it comes to their applications. Dr. Bless?
Yeah, I don't know what advice to give. Like, obviously, the political questions are, it's really stunning what is happening here, and it's very different. I think um, for any students that do come here, the faculty really, really care about you and about the research, and we try really hard to share like a little bit of ourselves, but also like a lot of our insights and passion for research. And there's a lot of decisions people make about with imperfect information. I think like if you find a school or a researcher that seems to think about the world the way you do and you want to work with them, like people are still people, even if the world is a little bit crazy. And so um if you come, we will work really hard to make sure you have like job opportunities when you're done and a intellectually really stimulating time while you're here, because that's our job.
Thank you so much for that reassurance, Dr. Catherine.
Yeah, of course. I mean, one, I would just like to say thank you to all of you for joining today's session. For those of you, I know the number reached above 200 earlier. For those 150 who are still here, wow, thank you for hanging out. Um, I would just let you know again, as we've already said many times, we are here to be a resource for you and a source of support. So if you have any questions or concerns, you are more than welcome to reach out to my office at engineering@gwu.edu. You're able to make one-on-one appointments with the admissions staff if you'd like to talk through any questions that you might have about the application process or about your future visa concerns, anything of that sort. We are here to help you. I would just draw your attention to a deadline if you are thinking about applying to GW. If you are thinking about fall 2026, the priority deadline for PhD will be December 1st with a final deadline of January 15th. And our master's students, that priority deadline will be January 15th. We will continue to accept applications after January 15th, but if you are interested in funding, getting your application in by that priority deadline is going to be most important because it is a first come, first serve basis. You might be a wonderful student, but if you apply in April, I will not have the same funding I had in January. But otherwise, we are here to welcome you. I will be in India in about 3 weeks, traveling with Seed. Potentially, if any of you are at the universities we're visiting, you might get to see me in person. We are still very enthusiastic about welcoming our international students to GW and to Washington, D.C. And I hope to see you guys here eventually.
Wonderful. Thank you so much, Catherine, for that summary. And thank you so much, Dr. Pless. And most importantly, thank you so much for the 142 of you that are still in this meeting and have heard through everything. We have gone 6 minutes over time. Thank you so much for everyone for accommodating. And, for your friends who haven't joined, we will send you some recording. And we'll also send you the application fee waiver because since you have registered and attended this session, you are lucky you're saving a couple of $100, which is the application fees that GW would charge otherwise, but now it's waived off since you have attended this session. Thank you so much once again. My name is Sharang, Seed Global Education. We keep bringing such masterclasses and keep bringing wonderful people like Dr. Clef and Catherine to your screens and soon to your cities as well. Thank you so much and all the very best. Bye-bye.
Thank you.
Thank you, everybody.